Good morning, everyone. As I was introduced, my name is Akihiro Kuroki. I'm working for government-developed Institute of Energy Economics. I'm in charge of the climate change, especially climate change, but including energy security itself. I used to work for land planning agency that I'm in charge of the metropolitan planning, town and city planning. So I have some knowledge, and I would like to show that our incident was occurred last 5 months. I also a nuclear engineer. I used to work for the nuclear safety department in Japan, and also work on the KIDO, Korean Peninsula Energy Development Organization, that used to work for constructing the nuclear power plant in North Korea. I'm in charge of the nuclear safety of that construction. So all my knowledge, with my knowledge, I'd like to share with our experience and knowledge and analysis about disaster that was occurred last 5 months. Okay, my first part of the presentation is earthquake and tsunami. And this year, first I'd like to explain the outline of the earthquake itself and tsunami and alert system and evacuation system that we prepare for this kind of disaster and how does it work. My concentration is why it doesn't work well. Okay. This is the outline of the tsunami, earthquake. Its Richter magnitude scale is 9.0. It's well known. So it's much bigger, much powerful than one of the most famous earthquake we have experienced in 1923. It's called Kanto earthquake. It caused more than 100,000 people's deaths in Japan. But compared with the magnitude itself, it's much smaller, less powerful earthquake than that occurred in this year. Please remind that magnitude M1.0 increase 25 times increase of the total energy. So it's a quite significant change if magnitude increase 1 or 0.5. Biggest earthquake in Korean Peninsula that was recorded only 6.7 in 1518. But there is still chance to have a bigger earthquake occurs because until this year, Japan never experienced a scale of 9.0. We used to have only 7.9, so could be happen in any country that more larger earthquake can happen near your country. Influence earthquake intensity is concentrated to the east side of Japan. You can see the red one is most severe one. Most high is 7, but in only one town. The other is 6 plus or 6 minus. Amazing thing is that the landslide of the sea bottoms. Japan installed a lot of GPS monitor in the sea bottom, and one of the monitor is just over the epicenter of this earthquake. That monitor moved 24 meters. I remember it's east, south. And you can see that there is a huge area move, more than 20 or 30 meters. The total earthquake land is north-south 500 kilometers around, and east-west is 200 kilometers. You can imagine the scale of it itself. It's not unclear until now how it happened. And obviously, the Japanese government already calculate that how possible earthquake in that area. At that time, the conclusion is there is a quite good chance to have earthquake up to magnitude 7.5. Our estimation is very much underestimated. Why it's underestimated? That is one of the explanation by Professor Ide. It was shown recently. I will not explain in detail, but there is a fourth stage of earthquake occurs. First stage, there is a very low frequency shallow part. It's rupture of some cloud. It's so low frequency, so human cannot feel it. The second one starts after that. It's a large part of the rupture of deep part and high frequency. It's called a tsunami, but it's not so. It's deep and high frequency. That tsunami is not so huge. The third part is a dynamic overshoot landslide. So it's overshoot. It contains, accumulate a lot of energy for a long time, and Japanese government estimate how much energy accumulated. And based on that, we calculate 7.5, but it's overslept. So that the earthquake is much bigger than that we estimate. And there is a big tsunami was occurred at that time. And the final part is this rupture of the deep part again with high frequency. So it's all over. It takes 1.5 minutes. It's a very long time. That's one of the reasons why Japanese government underestimated tsunami itself, because it's very long time, and we calculate a lot of data and mass data. That's the reason. This is an image of the landslide of the earthquake. Okay, you can see the time what happened. Small thing has happened, and large thing, second one is much larger than the first thing. Okay, let's go to tsunami. And tsunami is, of course, that there is a list of the largest tsunami in the history, and top 10. Amazingly, there is 5 from Japan. So Japan is a tsunami-friendly country, as I can say. And this one is around 40 meters high, is 10th biggest. And the death number is around 50,000 people. But there is other tsunami is much higher than that, cause a lot of deaths. And I can add a 1983 tsunami. It's only 9.8 meters high to Japan, but also impact to the Korean Peninsula. Okay, this is a whole spread of the tsunami to the Pacific area. You can see that Japan is a good barrier to protect Korean Peninsula from tsunami. Is there any tsunami could be threatened to Korea? Yes. In 1983, there is a tsunami occurred, and light graphs show from Kinsey's analysis that the highest tsunami observed is around 3 meters high. I believe there is a 2 or 3 deaths at that time was occurred. Japan Tsunami Alert System is established very early in 1952, and we aim to release a fast alarming less than 3 minutes. That's the target of Japanese government to establish. Why? Because tsunami can hit within the 3 minutes or within the 5 minutes if it occurs close to Japan. But this time, this 3 minutes limitation caused some problem to us. I will touch upon it later. This is an image of the wireless system of the tsunami warning. It's well established. most of the coastal village and city, they install this kind of tsunami alarming system. This is how many we already have a tsunami hazard map. Almost 2/3 of the city and town have a tsunami hazard map. No tsunami hazard map, mainly west side of Japan. There is less threatened from tsunami. So all the town and city in 3 prefectures that was hit by tsunami, they already have tsunami hazard map, like this. There is evacuation center was already indicated, and there is a red line. So within the red line, all people have to evacuate. This is well designed, well planned, and it works well because we have a lot of experience of tsunami. This is also another tsunami hazard map example. Past experience, this is show that in 1883, there is a big tsunami called 38.2 meters high. So there is a symbol. Tsunami can reach here. That's a symbol and alarming to the people. Why it didn't work well this time? Much tsunami ever experienced in most of the city and town. That's first reason, of course. And Japan alert system underestimates the height of tsunami. First alert is within 3 minutes. No enough information, but they calculate from the first movement of the earthquake, and they estimate the earthquake, the magnitude 7.9, much smaller than that real one. And based on that, the alarm is that Iwate and Fukushima only 3 meters, and Miyagi 6 meters. So I can assume most of local government people believe, okay, 3 meters, we can stay our office at home. Thank you for the tsunami protection. 3 meters cannot reach our town. Then 30 minutes later, they understand there is a mistake was made. So they upgrade the alarm from 3 meters to 6 meters, 6 meters to 10 meters. Still underestimate. And around 50 minutes later, finally they say the tsunami can over 10 meters. That's the limit of the alarm, so 10 meters. But it's already tsunami, after tsunami hit the coastal of Japan. And third reason, as I said, there is a 3-stage earthquake. So first stage causes some tsunami. It's less than 1 meter. So everybody say, okay, first time is only 1 meter. Tsunami alarming says 3 meters, so it's overestimated. So some people stay in his home office because of the first tsunami's height. Okay, I didn't bring data of the alarming system how work, but tentative result of our analysis say that 2/3 people heard a tsunami alarming that they have to evacuate. 1/3 people, we don't know the reason, couldn't hear the tsunami alarm. Maybe because of some electricity blackout, maybe that the speaker was broken, or other reason. Among the 2/3 people who already had evacuation, among them, half start the evacuation immediately. So it works. But half of that, as I said, because of the underestimation or other reason, they will stay their home to try to communicate their families, try to communicate their office, or try to go to the school, something like that. That's why most of people cannot evacuate immediately. So we need to improve, of course, tsunami alarming system, but to do something to people to immediately evacuate. Of course, we have revisited tsunami hazard map and other things. Okay, I will touch upon very little about the nuclear disaster because there is a panel 3. But my conclusion is one is the oldest reactor causes a serious problem. That's very end. Unit 2 and 3 and 4 could be survived if Unit 1 shut down before. Evacuation plan by Japanese government of Japan caused confusion or anxious among the people near the nuclear power plant. That I will tell you. There is a nuclear power plant around Japan, and 4 power plants were hit by tsunami. 3 of 4 can survive and can cool down safely, so there is no damage. But only 1 power plant, Fukushima Daiichi, have a major problem. This is an outline of Fukushima Daiichi, and there is a 6 unit, and Unit 4 is already shut down for the maintenance. 1, 2, 3, and 5, 6 is in operation. 5, 3 is safely cooling down, but 1, 2, 3 have some problem. You see that number 1, Unit 1 is oldest nuclear power plant in Japan. It's a BWR type 3, and containment type is Mark 1. That make a problem up to this Japanese power plant. In media, they say if there is no electricity, there is no way to cool it down to the nuclear power plant. That's why there is a meltdown to the Unit 1, 2, 3 of the Fukushima power plant. It's not true. There is still remaining cooling system after electricity was totally lost. Unit 1, there is isolation condenser. We call it IC. There is a 2 unit. It can cool it down to the reactor at least at a certain level. So if it works well, there is no meltdown. Unit 2 and Unit 3, there is some improvement, so they install a more modern one, reactor core isolating cooling system, RCICS. And this system works well for Unit 4, 34 hours they're working and make reactor stable. And Unit 3, for around 40 hours, almost 3 days. But Unit 1, we don't know why yet. The IC didn't work. Somebody say it's manually stopped between the earthquake and tsunami. So it's meltdown and caused a hydrogen blast and exploded a lot of radioactivity around the power plant. It makes impossible for people to access to the Unit 2 and Unit 3. So if Unit 1 is not there, we can access the Unit 2 and Unit 3 within the 35 hours and fix the electricity easily. That's my conclusion. Okay, how the evacuation order was made by Japanese government. First order is after around 5 hours after the earthquake. And first evacuation order is 2 kilometers from each unit. So very narrow range, but soon the evacuation order is within 10 kilometers because that we, Japanese government, believe there could be a meltdown in Unit 1. So the evacuation order is expanded. After that, there is a hydrogen blast at Unit 1. So evacuation order is expanded to 20 kilometers. And 3 days after the sheltering indoor order, it's very complicated. So people cannot understand what exactly what mean. But this order was sent to the people between 20 and 30 kilometer zone. And March 25, more complicated, confusing order was made, but recommended for voluntary evacuation between 20 and 30 kilometer zone. So people say, why it's voluntary? It's not mandatory, voluntary. Very confused. and also the April 22 set planned evacuation zone. So finally, total number of people who have to evacuate is more than 100,000 people. It's not a small number, so it's very difficult to manage these people to the safer zone. This is a map of the real, as I said, that's first. Secondly, we took 10 kilometers from Unit 1 to Unit 2, so you can see the, sorry. Oops. Be patient, please. Oops. This is the first evacuation zone set, 10 kilometers. There is a blaster here, so we expanded this one. And this is enough zone. But after that, we analyze a real condemnated zone. And it's not circulate. It goes to the northwest and easily to pass the 20 kilometer zone. This is 30 kilometers zone. Still, over 30 kilometers, there is a high containment zone. That's why Japanese government set this area, planned evacuation zone. So it planned and not immediate effect, but request and sent army to evacuate all the people from this zone. So, but it's very delayed. They worry about there is a confusion or some kind of confusion on these people, because there are a lot of people who live here. But based on this experience, we, Japanese government, have to improve or revise our evacuation plan for the nuclear access, because these steps have make a confusion. This is the end of my presentation, and I hope I can share with you some information regarding the last disaster Japan experience. Thank you very much.